So, welcome to Friday, 17 March. This is Founders Day and St. Patrick's Day. It's quite an interesting intersection of events in the history of UVI and the US Virgin Islands. Of course, St. Patrick's Day is a big deal in certain locations all over the world, but who'd have thought St. Croix is sort of an epicenter for St. Patrick's celebrations in the Caribbean. So, to those of you who plan to enjoy, uh, I hope you have a great time, and I hope we see you back on Monday. So please celebrate sensibly. Um, the assignment and solution for Module 3 is actually pretty straightforward. This is the Word document that you'll receive when you download the reference for assignment 2. I think it's 3.2. You'll create subnets. And in the first three problems, you're going to use the templates that are in place that you've already had a chance to download. So if you look in the website and you look inside the resources and references folder, there are CIDR templates. You'll see those in there. This one particular web page is going to look a little differently than the one you'll see in just a moment. The 3.2 assignment reads, first, watch this video on how to use the CIDR templates, and then use the attached Word document. Now, I've already explained how to use CIDR templates in class, but in case you need to refresh your memory, it's all right here. And when you click this link, that's the document you're seeing right here. So the first three problems use templates. You're taking a larger network and breaking it down into smaller, more efficient networks. A /26, a /28, and a /25. No, I take that back. Okay, so there's actually a fourth. So the fourth one's an extreme example. You're going to a /30. So problem number 4 is how you perform CIDR to an extreme. You're going from a /24 all the way down to a /30. And so you're creating many, many networks, but very, very few devices on that network. This is something you do in a high profile case where security is a maximum concern. It's it's of greatest paramount. So, and I actually stated that in a manner that would make most English professors cringe because I was really redundant in that expression, but I'm doing that on purpose so that everybody understands. This is a good practice to perform for networks where security is extremely important. You create smaller networks where there's only enough address and real estate to support the connected devices. If an adversary cannot engage your network, they cannot do anything. It is a seldom practiced but absolute slam dunk when it comes to securing networks. You only have so many network addresses, and all of those are taken up, so there's no room in the N, and adversaries simply have nowhere to go or to park or to poke their nose, and that's something we'll take up in Module 6 at the end of the semester, but I just thought I'd play that up a bit. After problem 4, there are 2 problems that involve supernetting. And supernetting is working in the reverse direction. So you start with a typical size of a network like a /16, a class B network, or a /24, a class C network. And instead, you slide the network mask, you reduce it, in this case by 2, so that you're creating a larger network. Now, one of the challenges of doing this is that when you work in reverse, you're combining smaller networks into a larger network, you're losing so many network IDs and broadcast addresses and gateway addresses. And if you do this in the public domain, you can end up with a network ID that's very different from what you see here. What am I saying? If I have a /16 where the network ID is 135.217.0.0, that's the network ID for this network, and I supernet, I create a larger network. On the public address range, I have to have internet service providers and organizations that own that are willing to cooperate with me. That's the first challenge. And in some cases, you don't have that. But assuming a large internet service provider or telecommunications company purchased a bunch of smaller internet providers, they could combine those address ranges. And if they shrunk the subnet mask to a /14, then perhaps the new network ID would be 134 or 132 or 128. The easy button that I'm giving you is this website. So in both of these cases, for problem 5 and problem 6, you're going to take the initial information, plug it into here, and then read the answer out. And I'm going to show you and demonstrate with this first problem how that works. And you'll also have access to this link, even if you're taking assessments and the exam. You can do this manually. You can do the calculations manually, but it gets to be a little tricky depending on whether or not other network address range owners are going to play team ball with you and so on. So in real terms, it's not performed as often. Can everyone see my screen?
Yes.
Yeah.
Okay, so this is a website that's provided courtesy of a German technology professional. So the .de represents Germany, Deutschland, right? So that's a country domain. And what we're going to do, you can use this calculator to calculate going smaller or going larger. But I want you to use the templates, because the templates basically provide a view of all the network address ranges simultaneously. What we do is we take the address, host or network, in this case we'll use the host, and we'll adjust. So we have 16, it's what we had previously. And on my problem, I'm going to put in 132. I'm going to change this up a bit so it's a little different, just so you can see. So yeah, I'm going to change this so that it reads 125 instead of 135, just because I want the outcome to be different than the actual assignment item. I'm going to move to a 14. So I'm shrinking 2 spaces. I'm moving to a 14. Does everybody see what I'm doing there?
Yes.
So we click calculate. And what this shows is the new subnet mask. It's not 255.255.0. Instead, it's 255.252.0.0. See how it's extended 2 zeros into the next octet. So I only have 6 ones instead of 8. And it shows that my network identity is 125.216.0.0/14. It shows my broadcast address. It shows my starting host network address. That's the router address. So the first one that's designated is typically used for the router or reserved for the router. On this website, it doesn't distinguish that. On this website, the first address is not the router address, it's just the first address that you can use. And by practice, most industry professionals just take this. But here's the acid test about whether or not you've done this correctly. What you'll see is that in the first network, before we made the change, you could host 65,534 devices. And if one of those is the router or gateway, then it would be 65,533. Okay. That's what a /16 does. If I supernet, I've decreased the subnet mask and increased the size of the network in terms of host capacity by a factor of 4. So 2 squared is 4. The resulting network can host over 250,000 devices. And in terms of public internet address space, that's huge. So that could be over 250,000 home routers, business modems, and so on, right? Does everybody understand what I'm saying here?
Yeah.
Okay. This is just a handy website. And again, you can perform the calculations manually. It's just a bit tricky. I find this website to be very useful, and I've used it for quite some time. So that's what you're doing for the assignment that is about to be posted. There are 6 problems altogether. I am not scoring your submission. Instead, I'm going to provide an answer key after the assignment deadline has passed, and I will simply post credit if you submit answers. But it's up to you to look at the answer key and see if your answers track with what the correct solution is in each case, okay? Does everyone understand?
Yeah.
All right. So if you do it and you see credit is posted, that doesn't mean you got it right. It means you got credit for the attempt, and you need to check the solution, the answer sheet against the problems to make sure that what you're calculating is correct. There will be many of these on your assessment. You will not want to attempt your module assessment until you do this assignment and you make sure you're getting the correct answers, or you will crash and burn and zero out on that assessment. And that's really demoralizing. I know I'm being a little dramatic here, but I'm just trying to save some of you some blood, sweat, and tears, okay? So just trust me, I've done this class for many years, and this is one of those where people just wing it and they're like, oh yeah, we got the drill down now. We know how a module works. And you just look up stuff in the study guide, right? No, this is a skills thing. It's not, you can't look it up in the study guide. You have to perform these tasks to know how to do it before you go into that assessment, or you won't pass. And then you have the reconciliation, which gets to be painful because you're repeating so many attempts of these solutions for each of those items on the assessment. You want to get good at this and efficient. And if you do this honestly, you'll be in good shape. You won't have a problem. Okay. So where are we with the solution? The solution, you use Packet Tracer and create some routes. We're going to want you to create some routes in Packet Tracer. There are videos that walk you through it. There's a section for additional credit. And I find that once people get the basics right, it's no problem doing the extra credit. But you're going to find that unless you have Packet Tracer set up and it's ready to go, unless that's in place, you're gonna hit a brick wall here. So you're gonna wanna make sure that if you haven't done that assignment yet in a previous module, that you have that ready. Essentially, network assignments, helpful tips, right? So what you're going to see, can everybody see the names here?
Yeah.
Yeah, I can see it.
Yeah.
Okay. Now, it pains me to explain why this is necessary. All right. On your assignment, on your solution, each of you are going to complete this solution, but you're going to do it with your own unique number range assigned. So, and what you're seeing here is the previous season's number assignments. So you're going to create two networks and you're going to set up a router in between, and you're going to set up the routes on the router so that one network can see the other network. The point of routing is to route packets that belong outside the network. It's a very simple thing, actually. Just takes a while to wrap your head around it. You have to have two different networks. So, and then you have to have a network between the routers. So what am I saying? You have a first network, which is going to be it's going to be a class C network, the kind you'd find in your home. Then you're going to have a second network, which is more like the kind you'd find at work. And then in between, at the top of each of those networks is a router. You're going to have a router on the 1.1 address. 1.1 is going to be the router address for the first network. 1.1 is going to be the router address for the second network. Of course, the rest of this is different, right? So those routers are going to be connected in turn with a third small network. There is a small network between the routers. What are we saying? You're going to have a local area network over here on the left. You're going to have a local area network over here on the right. And then there's going to be a router at the top, a router at the top. And then in between the two routers is going to be a third network we call the router network or router subnet. And the reason you're seeing names and specific address ranges, I want you to notice in the first row, all of them have this in common. The third number is a .1. Everybody see that?
Yeah.
Okay, now if I come down to James Warner, that's a .3, a .3, and a .3. Now, why did I do this? Because some students are cheaters. They have fraternity brothers. I'm not calling out any fraternities in particular, but when people turn in the same solution and it's the exact same solution, it's embarrassing. And it happened too many times, too often, and I got wise to it. And I said, you know what? Every student has their own ID, their own stuff. Now, that still doesn't prevent anyone from paying another student and giving them the information. I mean, in theory, and I'm just using James as an example, let's say James was too busy and he had a friend who was really good at this, you know, James could say, hey, make sure you build the solution with my numbers. The point is that students were lazy enough where they didn't do that much. They just copied and pasted each other's screenshots. And I got tired of reporting people to the Dean of Student Affairs for academic integrity violations and zeroing out their work. It became a real sour stomach for everyone. So I did this because I had to. And I just want you to understand why it's very important, not for you to do what? Well, let's say you watch the video and you do the same solution I do. If you copy my solution off the video and you have the same numbers I do, that's still copying. Does everybody understand?
Yeah.
Okay, so now what happens if the numbers you have happen to be the same numbers? That's your lucky day. I mean, if I happen to pick the same set of numbers that you were assigned on your particular, for your particular solution, then that's okay. but everybody else in the class doesn't have that number. And I would expect everybody else in the class not to have that same number. Okay. Now, once again, my apologies for calling this out. It just got to a point where it was really really third year in a row. Oh, hell no. Third year in a row. We're fixing this. We're going to rig this solution so that people do their own work. And what we found after we did that is one of two things happened. We found out that students either took the time to watch the link and watch the video and really pay attention, and they got it, and then they did well for the rest of the course, or students didn't take the time, they slopped it, they just sort of were multitasking or spitballing, you know, they were just in a hurry, and they turned in a half-baked solution, and they got partial credit, but they didn't really understand, and then they just said, well, I need help. And then it got awkward again, because I'd ask, which part of the help do you need? Well, you know, after this first part, I'm like, okay, show me in the video. Is it right here? And then we watch the video. Because the video tells you, shows you step by step what to do, how to do it. And sometimes it's fast, but you just have to back it up and play over a part. And what I'm telling all of you in advance is, and I hope for those of you who are not in the session today will watch this part of the video. And I hope you're leaning in and hearing this, because there are 6 students that aren't with us today. This is one time where you don't want to have a lot of distractions. You don't want to be multitasking. If you spend 30 minutes, honestly, watching this thing, and then you spend the next 30 minutes following the steps, the rest of the semester is easy. If you don't, you'll get frustrated, you'll get disgusted, then you'll get ugly with me, because you're going to say, well, I need help. And my first word to you is going to be, okay, I'm going to open the screen. I'm going to walk into the same video that the student, woulda, coulda, shoulda watched, woulda, coulda, shoulda paid attention to. I'm going to say, was it this part? Which part of it is confusing? Because what I'm expecting at this point is for you to have a specific challenge. If you try this command right here and you get a different result on your screen, that's what I'm expecting you to relate to me in a request for assistance. And again, I mean, it took hours to get just the right sequence of things for a demo video correct. And that's a huge investment. And it's paid dividends every year for students that actually take it one step at a time. Okay. So I know that's a bit of a rant, and I want you to bear with me, because I don't really rant that often, right? I mean, I don't really go nuts about a topic as a regular practice. This is one time where I really want everybody to hear me. And I'm going to call the 6 people who aren't here in class, and I'm going to say, hey, the last part of this recording, you need to spend some time and listen to this. Take this to heart, because you don't want to be one of the 6 poster children, because that's really what it comes down to. It's like, really, we're sophomores or juniors now, and I've got a YouTube video. How hard is it to follow a YouTube video step by? Don't tell me you need help because you can't figure out what comes. Now, if you do a no-shut command and you don't see a similar result, then call me. I will post additional credit because something weird is going on. The new version of Packet Tracer works differently. The interface doesn't function properly for one reason or another. You're engaging me at that point, and we're doing a collaborative troubleshooting session, and we're investing blood, sweat, and tears in solving your problem. And I will post additional credit for bona fide assistance requests. But I will call you out and I will replay this part of the video in this class, and I will call you out and say, that's not a bona fide, with respect, that's not a bona fide assistance request, okay? We don't have as much runway for the rest of the course. And if it takes me 3 weeks for students to clear this solution like it did 1 year, I'm just gonna post zeros and leave the rest of you in the dust if you can't get a clue and pull your act together and get your stuff straight, okay? So this is one of those locker room talks where the coach is like, you know, we can't afford to lose this game. So I need everybody here. And if you need to like take a drink of water or you know, shake some stuff off, then get up and shake some stuff off. That's the spirit or intent with which I am delivering the message today. And so I hope everyone understands. Are there, I know I was a break from the typical format. Are there any questions or interests or concerns? Would anyone care to ask any questions about the expectation for the assignment and solution I'm about to post? I think if you do it, you'll actually be pretty amazed. It's a cool, it's a cool set of activities. And when you finish them, and if you get the answers right, you'll be like, I got this, I know this. And the rest of the semester goes very, very well. So this is the one time in the semester where you don't want to rush things or slop things because it's a slippery slope. It gets very frustrating very fast. Okay. Are we okay? Did I scare anybody?
No.
You're not all ready to run out of the room with your hands flailing above your head. Where's the green beer? I'm ready to start St. Patrick's Day. Enough of this. Okay. Well, do enjoy the weekend and shoot me a quick email if you run into a snag. If it's something simple, let's get it resolved. And then by early next week, we should be ready for an assessment, okay? That's it for today. That's all I was going to share with you.
All right. Have a good
All right.
weekend.
Let's see.
Oh, Dr. Kentop, I have a question.
Yes. Do you want me to stop the recording?
Yes, please.
Okay. Let's stop sharing and stop the recording and then just hang in.
Mm.